So, just to finish up the hormonal system this week, let's chat about download, not download. Hold, please. Okay, there we go. So, last week that we went over the endocrine system already. I put up the notes for you. So far, you should know the difference between exocrine and endocrine, paracrine and autocrine, know examples of each, be able to define those. We went over the essentially all of the glands that you have. You should know the glands. You should be able to recognize them. And we have endocrine tissues that you should be aware of, and you should know all of the endocrine hormones that are secreted in here. You should know all of those hormones and what they do. Then you should make a list. What are the hypothalamic hormones? What are the pituitary hormones? There's 7 anterior and there's 2 posterior. You should know what they do. You should know what triggers them. And then you should know the relationship between the hypothalamus and the pituitary. That is called the infundibulum, the hypophyseal portal system in there. And then we talked about what you should know about like this relationship between the hypothalamus and the pituitary, and then each of the organs. You want to do well on your test. You should be able to tell the story of hypothalamus, pituitary, organ, and be able to go through that and tell me what happened. So we went over the thyroid. You should be able to do that with the thyroid. You know, the hypothalamus is going to, in response to low T4, it's going to secrete TRH, and then the TRH is going to stimulate the pituitary to secrete TSH, which is thyroid stimulating hormone. And thyroid stimulating hormone is then going to tell the thyroid to secrete T3 and T4, and T3 and T4 are going to go and do what? They go to every single cell in the body, and they have to do with metabolism. You should be able to do that with all of them. If you can do that, you will do well on your test. If you can't do that, maybe you get things right, maybe you get things wrong. But I'm telling you right now, the expectation is that you should be able to do that. You should be able to take a whiteboard and draw it out and explain it to somebody for any of those hormones. If you can do that, you're great. I know that's a lot of stuff and it seems confusing, but you just need to organize the hormones in your head. Remember the hypothalamus, you should know the functions of the hypothalamus. Remember body temperature. It's going to be your metabolism or your hunger, your sex drive, all of that stuff. It regulates kind of the autonomic functions of the body. And then the hormones are either going to have an R or they're going to have an I in it. They're mostly releasing. So if you have an R in it, you know it's a hypothalamic hormone. And it's going to go. And the hypothalamus only talks to the pituitary. Remember, there's always this relationship. It's going to be the hypothalamic, pituitary, and either if it's the adrenal gland, the adrenal axis, the thyroid axis, the gonadal axis between your testes and your ovaries. And then you should be able to go for steps and steps. So remember, the hypothalamus only talks to the pituitary, and the pituitary, its hormones are going to stimulate the organs, and they're going to either release their own hormones or they're going to release whatever they do. Like a mammary gland is going to release breast milk in response to prolactin. So, you know all the hypothalamic hormones, you know the 7 pituitary, posterior and anterior, or 7 anterior, 2 posterior, and then know any of the hormones that any of the organs secrete and know the functions of those, and then know how it's regulated through the negative feedback loop. That's why they give you 2 weeks to do this. And make sure you can recognize where they come from. So that's all this chapter really is. It's knowing the difference between endocrine, exocrine, paracrine, autocrine. No examples of those. Know the relationship between the hypothalamus and the pituitary, which is your infundibulum that has the hypophyseal portal. You know the hypothalamic hormones, what they do, what they secrete in response to. You know anterior,
the 2 posterior, right? And then you know all the hormones that your adrenal glands are going to secrete. You know what your thyroid is going to secrete. You know your ovaries. You know your testes. And then you know how that whole system works, how that negative feedback loop works. So just go through it and drill it and over and over and over again, like you can explain it to somebody. And if you can do that, you're going to be great. Then the last part
is what is the difference between soluble and water soluble? There's like two different parts to it. One is transport through the blood. Two is what happens when it gets to the cell membrane. Can it go in, or does it have to use a receptor on the outside, secondary messenger? You can do those things in this chapter. You're going to be great. If you can't do them, and you can't say them, you can't speak them, you can't write them, maybe you get them right, maybe you don't. But when the stress of the test hits, you want to know this inside and out. All right, that was all of that. So now, some other things that we need to talk about with this chapter. One is blood sugar regulation. So blood sugar is super important to the body. Why? Well, what is blood sugar? Blood sugar is glucose. You know, what is glucose for? What do we need that for? This is your energy system, energy. Now, you can get energy from other carbon sources like fat. That's the idea behind a ketogenic diet. You don't eat carbs, and you get it from fat and protein. But our body loves glucose. It's quick, it's cheap, it's easy, it's fast. It's like super fuel. Like if you want performance, glucose is the way to go. Like that's if you're working out, you're exercising, you're running, like you're doing cardio, that's glucose. Every single cell in the body is going to use it. What happens? You put glucose where? You put it into the mitochondria, right? You got our mitochondria. What do you put it in there with? You put it in there with oxygen. And then what happens? It creates ATP. So think about this. We learned about homeostasis. We have a homeostasis for glucose. What is that? It's about 70, probably went a little higher than that, to about 99. Is that milligrams per deciliter or something like that? This is where you always want your blood sugar to be for the most part when it's fasting. When you go to the doctor and they tell you you can't eat, this is one of the reasons. Oh God, I didn't eat it. And it's funny. Like I could go days without eating and be okay, but as soon as somebody tells me I got to fast, I'm just like, oh God, I can't eat. If your blood sugar goes too high, what happens? If it gets too high, like specifically over about 128 on fasting, what is that called? It's called diabetes. You don't want to get that. Why though? Why is diabetes a problem? Like that's the thing. A lot of the patients that you're going to have are going to have diabetes. Now, there's two types of diabetes that we're going to talk about, but why is it important to manage your blood sugar? Because you're talking about your energy system. If your glucose, like physiology, your glucose control sucks, you're talking about every single cell in the human body is not getting appropriate fuel delivery. Your brain cell, heart cell, liver cell, lung cell, kidney cell. That's one part of it. It's not getting good fuel delivery. So it's going to break down at the molecular level. You know that diabetes, uncontrolled blood sugar, increases your risk for all-cause mortality, which means everything you can think of dying from increases with diabetes. Heart attack, stroke, cancer, dementia, all the four horsemen of the apocalypse. Diabetes increases your chance of that. So when we're talking to our patients, a lot of them are just like, oh, my sugar's high, right? I got patients that tell me, it's got high sugar. I'm like, no, you don't have to have high sugar. Like, you have a problem with making ATP. You're not making energy for all of your cells. The other thing is that the elevated levels of sugar inside your bloodstream causes damage to your organs, cause damage to your arteries, cause damage to your kidneys. You combine that with high blood pressure, uncontrolled high blood pressure, uncontrolled diabetes, you're looking at dialysis in the future. I'm not trying to scare anybody. Just trying to put the seriousness into, we say these things a lot. We say, oh, you've got high blood sugar or high blood pressure. Those are the things that's not going to kill you right away, but keep on doing it long enough, eventually that's going to get us there a lot faster. So that's what It was when blood sugar gets too high, right? It's over 128 fasting. It's also called hyperglycemia. Now, what happens if blood sugar gets too low? You probably felt this before. Anybody ever get hangry, right? You get hangry, just so hungry, just mad at everybody, no reason. Had this, I've, I've had this fight a million times, right? Hey, what do you want to eat? "Mm, I don't care. Oh, okay, let's go here. I don't want to go there. Okay, what about going here? Ah, no, I don't like that place. There's- Okay, how about here? No, I don't want to go there. You said you'd go anywhere, right? So, well, why are you getting mad at me? And then it starts this fight because both of your blood sugars are so low that you don't have enough glucose to go to your brain. I know you didn't come to this class looking for relationship advice, but let me tell you, one thing that can solve, I don't know, I non-scientifically estimate 50 to 75% of fights is making sure that you and your significant other are fed in a fed state when you're having a conversation. Because that Snickers commercial is for real. Like, you are not you when you are hungry. Because why? Your brain relies almost strictly on glucose for energy. So once that goes down, like, I can't think straight. I'm mad. I can't control myself. My feelings. I'll start raging. Beyond getting hangry is also the chance of death and coma. You ever seen anybody that's taken their insulin and then has forgotten to eat and their blood sugar gets down to like the 30s, 40s, 50s? They're basically non-responsive, like shaking, sweat, and then you give them some sugar and all of a sudden, whoop, they pop back up. Hey, what's going on? So low blood sugar, that's bad too, right? This is dead. Diabetes, this will kill you slowly. This will kill you real fast. So we want to make sure we keep it there. So how do we do that? We've got homeostatic mechanisms to do that, and it's regulated by your endocrine system. There are some hormones that are involved in that, mainly done by the pancreas. Remember, the pancreas is a cool organ. It's endocrine and exocrine. Endocrine, it's going to secrete hormones. Exocrine, what's the exocrine function? The exocrine function is it's going to secrete digestive enzymes in here that are going to help break down those carbohydrates, fats, and proteins. We're going to have different cells. They're called islet cells that we have in here. We're going to have alpha, beta, delta, epsilon. Really, we're going to be only worried about alpha and beta cells. Okay, so we know blood sugar needs to stay where it is. Too high, diabetes, hyperglycemia, not great. Too low, diabetic, hangry at best, coma at worst. So now, let's just say you're like me and you get up in the morning, the first thing you do is you just drink a cup of coffee. You're like, meh, I don't need to eat. Some people do this on purpose. They call it intermittent fasting. So they're like, oh, I'm just not going to eat. I usually do it because I just trying to get to work as soon as I can. So what happens? You're going through your day and your blood sugar, like in the morning, let's just say it's about 85. You haven't eaten anything at night. So as you're going, your blood sugar, what's going to happen to it? It's going to start dipping and dipping and dipping and dipping and dipping and dipping until you get to a point where your body's going to set off some alarms and it's going to say, bro, you need to go eat. You realize that you're getting angry for no reason, or you start feeling a little shaky, you start feeling a little fatigued. But sometimes you can like just break through that. Like, some people fast for like a month. They don't eat anything and they don't die. Well, what happens? I mean, your blood sugar keeps dropping, you don't eat anything. I mean, that's normally how you raise your blood sugar. So how do you raise your blood sugar if, well, you got some backup mechanisms. You got some backup mechanisms for blood sugar. If we eat sugar, we're not in excess calories. What are we going to do? We're not just going to like get rid of it, right? We store it. How do you store sugar in your body? You're going to store it as glycogen. Glycogen is storage glucose. It's like starch, but for humans. How else can we store energy in our body? We could store that as fat. We got fat. So we can get sugar from here, and we can get carbons from fat. We can get glycogen. We have to break it down. Imagine there's these long chains of glucose. What do we got to do? We got to cut them up. That's called glycogenolysis. Lysis means to cut, so you're going to cut glycogen. The other way is that we can get glucose, but we can make it from some other stuff. So we got to make stuff. So that's going to be beginning of something. It's genesis. And then we're going to make glucose. That's gluco. And then we're going to make new is neo, gluconeogenesis. So we're going to take from fat and some amino acids, and we're going to put it together, and we're going to make glucose so that we can up our blood sugar, or we can break down glycogen. So those are the two mechanisms to elevate glucose back up so that we don't die or get hangry. What is the signal to our body that our blood sugar has gotten, that when it's gotten too low, to do this stuff, to do glycogenolysis? Or to do gluconeogenesis? That is going to be the hormone glucagon. How do you remember that? Well, when my glucose is gone, I'm going to secrete glucagon, and it's going to tell all the cells in the body, hey, start like doing stuff to make your blood sugar high again, so I'm not driving like a maniac, or so that I can focus and get attention on what I'm doing. If you're going to study, make sure you've eaten something. Your brain will work a lot better. Okay, perfect. So we know what happens when our blood sugar drops. Now, what happens when you eat? What happens to your blood sugar when you eat? Say I just had a Krispy Kreme donut. I did not. I drove by it today. The hot sign was on. That's because I have a Krispy Kreme donut gift certificate in my wallet. But I'm trying to be a good person. I'm trying to live a good life and not eat terrible foods, because the holidays are coming. And there's going to be all sorts of terrible foods to eat. And I'm a weak person, and I'm going to eat bad food. So I don't need to do that right now. Christmas is coming. All the cakes, cookies, and pies. But what would happen if I ate a Krispy Kreme donut? That's mostly made of glucose, right? So you put the glucose in your body. You're gonna absorb it. You're gonna use the digestive enzymes to break it down. It's gonna get into your bloodstream. So you put sugar into your bloodstream. Now what's gonna happen to that 70 over 99? It's gonna spike up to like 140. There's also some amino acids. Maybe you had some sausage or something as well, and some of those amino acids are gonna get in there. Probably some fats from the oil, that's also going to get in there. So now you have all of this, you have all of these macromolecules that have been broken down. You have all these monomers. They're sitting in the blood, and your blood sugar is high. Where should they go? Do you need to use them in your blood? Or who uses them? Who uses all that stuff? Who uses the energy? Who uses the amino acids? Who uses the fats? Yourself, your tissues, right? So it's in your blood. Your body needs a signal to put it all away into your cells. I don't know if you've ever worked somewhere and you get a shipment of stuff. Like when I worked at the restaurant, we get dry goods. They'd show up with napkins and plates, and then they'd show up with wine, and they'd show up with meat, and they just like the person would just come in and dump it right in the middle of the kitchen. So we'd have to go find people and be like, all right, we got to go put this away. Insulin is the molecule that your body secretes to tell your body to put all that stuff away. Or you can think of it like this, like sugar is like children running around in a classroom or in a school. They're just running around the hallways. That's your blood vessels. Where do the kids need to be? They need to be in class. Insulin comes along and it grabs these kids, and it's like, what are you doing? You kids. And it grabs them and it starts stuffing them in classrooms. Knocks on the door. Hey, classroom. Insulin here. I got these kids. Start stuffing them in there. Or it tells your body to start putting stuff away. It said, put the sugar into the cells. Take those amino acids, start making proteins inside of a cell with that. Take those fats, start making triglycerides with them. Go store those in the fat cells. That's what insulin does. So blood sugar goes down, the glucose is gone. We're going to use glucagon to bring it back up. Blood sugar goes too high, We're going to secrete insulin. Insulin is going to put the blood sugar into the cells and bring it back down. Alpha cells make glucagon, beta cells make insulin. Don't worry about somatostatin. And that's what all these slides say. Okay, so you eat and blood sugar does what? We eat a donut, that's going to put sugar into my bloodstream, it goes up. Do we want it to be high? No, we got to put all that stuff away. We got to make it go down. What do we do? Give them insulin. Insulin delivers glucose to your liver, skeletal muscle, adipose. That glucose can get stored as what? Glycogen. The fat that we ate can get stored as fat, triglycerides. All right. You've been working so hard, you're a nurse. Listen, there's going to be days when you're supposed to eat lunch, but you're so busy that you will not be able to eat lunch. So what's going to happen? Do you just die? You're just like, well, I mean, hopefully not. You'll be like, oh, my blood sugar dropped too low. No, your body has mechanisms to keep you going. Like back in the day, we couldn't just go to McDonald's. Like 150,000 years ago, when we were hunter-gatherers, we didn't even have crops. Like we had to go and find stuff, and then we found it. We would eat and gorge ourselves on it. We'd store it, and then like we're like, oh man, I don't know if we're gonna eat again for a little while. Like we didn't have refrigerators to store stuff. Stuff went bad. So now we're like, oh, what are we gonna do? I haven't eaten. Oh, good thing we have glucagon. So your glucose is gone. Then what happens is you're gonna release glucagon, and that's gonna take your glycogen, start breaking it down, increase your glucose. It's gonna start pulling out fat. And use that for energy. And that's what this is saying. All right. There's also one hormone that's important here that we can talk about as well, and that is cortisol. Sometimes when your blood sugar drops so low, or you get, and I know this is kind of weird. Let me see if I can find it in here. Let's see if we can find it's growth hormone. Ah, nope, that's thyroid hormone. Ah, cortisol. All right. So I think cortisol is an important topic to discuss because it does have stuff to do with these are called cortisol is a part of a group of hormones called glucocorticoids. Glucocorticoids. So obviously, corticoids. I think that's how you spell it. Obviously, it's a steroid, and it has to do with glucose. All right. So it's also known as a stress hormone. So let's talk about it. Fight or flight kicks in. All right. We learned all about that. You need to get your way out of a situation. You know, you got someone that's going to try to fight you, or you got to run from something, or you got to think your way out. Hopefully, you're going to try to think your way out. So what do you need to do? You need to get ATP to your brain. You need to get ATP to your muscles. You need to get it to your heart. You need to get it to all your cells. So would you want your blood sugar in a stressful situation to go down or to go up? You want it to go up, right? So cortisol is actually a hormone that can do that. So what it does is it actually increases your blood sugar levels. And so the blood sugar can go up to your brain, and so that your brain might be able to think a little bit better. You ever been in like a super stressful situation, all of a sudden, like you're driving in your car and somebody cuts you off, and you just narrowly avoid it, and now you're like, "Ooh, I'm wide awake," or you almost like fall asleep while you're driving? Well, that's cortisol. Or you're laying in bed at night and you're thinking about everything that you've ever done wrong. You're thinking about conversation you had when you were like 13 years old. You said something really stupid, and you're just like randomly thinking about that, keeping you awake at like 1 a.m. Yeah, you can blame cortisol for that. So cortisol, where is it secreted by? It's secreted by the adrenal cortex, the outside, and it's usually in response to stress and very, very low blood sugar. The adrenal cortex, so this is what you should know this. The adrenal cortex, remember, it doesn't decide to do anything. Who tells the adrenal cortex what to do? The pituitary. What does the pituitary do to stimulate the secretion of of cortisol, adrenocorticotropic hormone from the anterior pituitary. But the anterior pituitary doesn't do anything on its own either. It gets its marching orders from the hypothalamus. It is a hypothalamic hormone. We know that it is going to be an R, so releasing. So we have a corticotropin releasing hormone that is going to stimulate the anterior pituitary to release ACH. ACH is going to stimulate the adrenal cortex to secrete cortisol. Now, what is cortisol going to do? Cortisol is going to go to your liver, your adipose tissue. It's going to stimulate lipolysis. What is lipolysis? We're cutting up my fat. We're going to use that to make energy, mainly for your muscles. Gluconeogenesis. You're going to make new glucose. Right? What are we going to do that for? So that we can raise our blood sugar, so we can get ourselves out of this stressful situation. It's going to break down protein so we can use amino acids for energy. This is why cortisol and stress are bad long term. Now, this will help you get out of a short term situation. But if you're bumping this all day, what's it going to do to your blood sugar? It's going to elevate your blood sugar. It's going to elevate your blood pressure. It's going to break down your muscles. This is not good long term. Short term, yeah, it's great. There are drugs that work like this, like our steroid drugs, they work like this. One of the side effects of steroid drugs, well, one of the reasons we use them is to reduce inflammation. But what's one of the side effects? It raises your blood sugar. That's why they're not great to use. So that's our stress hormone, cortisol. Get stressed, hypothalamus releases corticotropin releasing hormone. That stimulates the pituitary to release ACTH, or adrenocorticotropic hormone. Adrenocorticotropic hormone stimulates the adrenal cortex to secrete cortisol. Cortisol then goes to the liver and adipose tissue, says, all right, break up the fat, create more sugar, break down our protein so we can use some of that for energy. Because, like, you normally don't want to do that, but if you're in a survival mechanism, your body's going to do anything it can to survive. It doesn't care. It's like, well, we don't need that muscle. So you are a workout person, and you're trying to get swole, and you're trying to get big, and you're trying to lift weights, and you want to get stronger, you want to get bigger. Getting enough sleep and living the least stress lifestyle you can is just as important as lifting. It's just as important as exercising. Because your body does not get stronger when you lift, it gets stronger when you rest. So if you're in the gym 7 days a week and you're only getting 5 hours of sleep and you're waking up to go at 5 in the morning to the gym, and you're like, why is nothing happening? Like, oh, I'm not getting bigger, I'm not getting stronger, I'm not losing weight. Cortisol, stress. Like, if you look at the power lifters and bodybuilders, you know what they do? They go and work out, and then they like go and walk on the beach. They don't even want to stand. Like, they'll sit down and play video games and just chill all day because they know it's not good for muscle growth. And it's not good for us. Stress and sleep are two things that we just kind of give lip service to, but we don't pay enough attention to. Some of us don't have a choice, right? Some of us work like 17 jobs and have like 3 kids, and you got to take care of your parents. And our jobs don't pay us anything, and our mortgages keep going up, and insurances go up, and like, and we're like, hey, you should just probably manage your stress better, right? Get it. But this is important to know. And stress is like the great mimicker of all things. Like, people can get like chest pains. They can get, I get patients all the time that come in for pain and stuff. And they usually, when I have a conversation with them, we're finding out like, oh yeah, my mom moved in with us and I got to take care of her now. Like, yeah, no wonder your neck hurts. Like, you got an evil 15-year-old at home that's just like fighting everybody. Yeah, it's right here, like right here in your trap. I know that has nothing to do with the class. So that was just talking about the stress response. Also, with the stress response, you could also get adrenaline. This is epinephrine and norepinephrine. This is adrenaline and noradrenaline. These are the same thing, except one was discovered in one place, one discovered at the other. They're discovered about the same time. These are from the adrenal medulla. these are going to stimulate the sympathetic nervous system. So put you into that flight or fight system. All right, I think that's good for now. I think that just kind of gives you blood sugar. Oh, so let's just real quick talk. So the two hormones that are really going to be involved in regulation of your blood sugar is going to be insulin and glucagon. Make sure you know what those are. Cortisol does play a semi sort of role in blood sugar, but not really. I can go over these later, but I want you to get the real important stuff. Oh, yeah, so let's just chat about diabetes for a second. So diabetes, there's type 1 and there's type 2, and then there actually is kind of a 1.5 in here at some point. So with type 1, what happens is you have a pancreas that produces insulin when you're a baby, but then all of a sudden, like pancreas, all of a sudden those beta cells get destroyed, usually an autoimmune attack. What happens? You eat sugar, and what's going to happen to it? It's going to go to like 1,300,000. You can't, you're eating all this sugar, but what's it doing? You can't absorb it into your cells because there's no one to come over and be like, cell, hello, I got sugar here. And it's just floating all through the hallways and it never gets into the cell. This is actually a wasting disease. Most people died of this when they had it because they couldn't get energy, right? They would just waste away to nothing because no sugar could get into their cells. So along comes some scientists and they actually figure out, hey, we can get some exogenous insulin in people. So you eat, you inject a certain amount of insulin, this goes back down. So these patients have to monitor their blood sugar all the time. They have to kind of know how much they're eating, and they got to give themselves insulin. Nowadays, they got pumps and monitors. They got all sorts of cool stuff now that makes it a lot easier. But very important, you have to kind of regulate your glucose, or else it gets too high and or it gets too low. Or like a patient that I had the other day. They took their insulin, they got busy, forgot to eat, came into my office, just shaky and everything. They checked their blood glucose. It's like 70, 60, or like 60 something, 50s, 58. It felt really bad. I have little snack things in for my kids, one of these like little applesauce things. She squeezed it in her mouth and like drank a little juice and instantly felt better because it brought her blood sugar back up. Type 2, this brings in the idea of insulin resistance. So you're just crushing food. You're, the word is hypercaloric. Hypercaloric. That means you're getting a lot of calories. And you're getting a lot of, and again, some of this is genetic. Again, bad genes, bad lifestyle, bad luck. Some of this is genetic, some of this is lifestyle related. So you're increasing the amount of calories, you're increasing the amount of sugar. You keep bumping insulin up, insulin shows up to the cell. These are called GLUT4 receptors that it responds to, that it puts sugar into the cell. Because remember, sugar can't just go in. It's hydrophilic. It can't pass through the membrane, so it's got to have a channel that it goes through. Insulin comes in, knocks on the door, and says, "Hey, I got glucose. Can you let him in?" Yep, let him in. 5 minutes later, "Hey, I got more. I got more." Finally, the cell's like just packed full of glucose, and the cell says, "You know what? No, we're not, because it's too full in here. You're going to damage the cell." And so what happens is you develop what is called insulin resistance. Finally, so many people just keep knocking at your door, you're not going to answer anymore. So insulin comes in and knocks on the door with glucose, and they shut the lights off. Insulin and glucose are sitting out there going like, "Hey, what's going on?" Like, nobody's home. Leave it on the doorstep, right? So if it's out in the bloodstream, what's going to happen? Your glucose is going to go up. And then what's happening? Your cells are starving. They're not getting enough glucose inside them to make enough ATP. It's called insulin resistance. And that's what type 2 diabetes is. Eventually, what happens is your pancreas has to crank out more insulin. And then it gets a better response. And it cranks out more insulin and more insulin. And then eventually the cells are like, "We're definitely not responding to any of this. And then the pancreas starts to kind of wear out. So generally, we have to treat this. Usually, you want to treat it with lifestyle. You diet interventions, exercise, decreasing the amount of calories. Those are all things that can help. But then there's drugs that help sensitize the cells to insulin. There's cells that increase insulin production, and then it can eventually get so bad that you have to be on insulin as a type 2 diabetic. What are the symptoms of diabetes? There's 3 good ones, and they all start with poly. There's polyphagia. What does phage mean? To eat. They're always hungry, always want to eat. Polyuria, you're going to pee a lot. And then polydipsia, always thirsty. And those are all kind of related to either you're not getting blood sugar into the cell, you're having a ton of blood sugar that escapes into your urine, you just start spilling it out into your urine, you get glucosuria, and then that is osmotically going to pull water out of your body, and it's going to make you dehydrated, so it's going to make you drink more. You're going to start drinking tons, and it's going to make you pee too. Those are some early symptoms of, or later symptoms of diabetes. Then you start getting some other ones where you start getting neuropathy in your feet. You can't feel your feet anymore because you damage the vasculature and you damage the nerves. So type 1 diabetes, the pancreas doesn't produce insulin, and glucose goes up. Type 2 diabetes, the body stops responding to insulin. The cells stop responding. Glucose goes up. All right, that's it. Now, you could also look through here and make sure you understand all these other hormones and kind of what they do. I'll make a separate video for that. But I think the other ones are really important.